Firstly, what is the dominant view on this kind of thing in the philosophy of science nowadays? So is falsification still a popular theory?
Yeah, I'd say probably not. I mean, the whole issue of the logic of science has to some extent gone off the boil. People prefer to talk about sociological questions and examining how scientists think. But there are still things. I just looked up today the latest issue of the British Journal for the Philosophy of Science, and it still has some of these questions and talk about confirmation of theories. But the theories, it seems to have got very complex, what people say. Probably falsification as such is regarded as kind of outmoded. But and Bayesian philosophy of science is a leading theory, but there's a lot of people who don't agree with it. It's hard. People have different versions of them. It's hard to see, kind of hard to understand where the field is going. But one thing that has certainly got a lot of attention that certainly adds to it is talk about explanation in science. So people talk about besides a theory being verified by its consequence, people say it's good for a theory to be simple and explanatory. So they're kind of internal things to the theory as opposed to its relation to evidence. And what those things mean is very hard to pin down exactly. But so people have been looking for the features of scientific theories that are good making features, other than simply agreeing with the evidence. Because you could have a very complicated theory that agrees with the evidence. That's just kind of a summary of the data that doesn't really tell you much.
Second question. Would you say it's possible for a falsificationist to also be a scientific realist? Because it seems like scientific realism is the view that we ought to believe scientific theories. So, if these theories can't be proven correct, not even probabilistically, would you say it's possible?
Yeah, well, Popper more or less said he was a realist, but it wasn't terribly clear why. He didn't seem interested exactly in that theory. He was only interested in, well, the logic of science. But certainly, if you're not going to believe theories at all, well, you're not going to believe in the realist aspect. You're not going to think they get to reality. But but on the other hand, what does Popper think about things where there's no kind of problem about the reality of the entities, like all ravens are black? Well, there's no doubting that there are such things as ravens, and you pretty much know what they are. So Popper will be realist about the ravens there are. It's just that he doesn't think you should put belief. You're rational to believe that all ravens are black.
Does scientific practice differ depending on what kind of philosophy of science it's based on? And is scientific practice based on falsificationism or verificationism or probabilistic theories or other things?
Yeah, so this is a question about scientists and how they behave. So this is a completely different question, because scientists, almost to a man or woman, say they're not interested in philosophy of science, and they don't think philosophers of science are telling them anything. If they read philosophy of science, they say, we don't recognise this, we don't see it. So you could ask, probably the next question is to go and study what scientists are doing and say, are they following some kind of methodology? And pretty certainly they are. And so pretty certainly the scientists who were immediately convinced by the observation in West Africa about the bent light, surely whatever they said about themselves, they are believing that things are more probable, and they're shifting their belief, and surely rationally so. So it's very hard to get philosophical sense out of any practitioners, as you probably know, whatever you're doing. I remember a philosopher of mathematics saying about trying to ask mathematicians about philosophy of mathematics, which they're notoriously bad at. He said, well, fish are good at swimming, but they're poor at hydrodynamics.
To what extent do false philosophies of science and falsificationism in particular undermine our scientific theories? Do you have any examples, please?
Well, they would undermine them if people were taking the philosophy seriously. Now, probably scientists are not taking seriously philosophy of science of this falsificationist or deductivist kind, because you can see them out there doing the experiments and believing things. Sure, in their grant applications they say, well, we've confirmed our theory so far, just give us an enormous grant and we'll confirm it some more and we'll cure cancer, etc., etc. And, but on the other hand, maybe some other people are not. What about the humanities crowd? Yeah, they're much more dangerous to science. Perhaps they, people in humanities are telling students who are going to be the public servants of the future and deciding on grant funding that science is not believable and that you should put the money into something else. We won't speculate on what that might be.
There was a question missed as well, just in the above, which is, does scientific practice differ between fields, so biology, physics, chemistry, their methods?
Yeah, well, there are certain differences, whether maybe you should call them methodological. So, according to what I said, according to basic philosophy of science, that method, the methods of basic philosophy of science, are applicable across the board in all sciences and beyond science, like in law courts and so on. So to that extent, the methodology is the same everywhere. But you can see differences between, undoubtedly, you can see differences in how things are in the social sciences and how they are in natural science. So social sciences, they deal with humans, economics, sociology and so on. And that gives you an opportunity to kind of understand things in terms of your understanding of human motivation. There's the German word Verstehen, which is said to characterize the social sciences. And it literally means understanding. In this context, it means understanding how people think. So surely, if you're studying psychology, you can understand that you're studying minds, and children from the age of 3 up develop a theory of other minds, as they say. And they understand that other people have minds like themselves, but amazingly, sometimes those minds think differently to others. So even 3-year-olds can understand that although they hate broccoli, there is sometimes adults like broccoli. It's kind of weird, but other minds can think differently to themselves. So that's a methodology that you can apply in social sciences, but that you can't apply in natural sciences because you can't understand what it's like to be a tree or something. But there is also some other opportunities for methodology in, say, economics. You seem to be able to do some things by pure thinking. So what about the thesis in economics that if the government prints more money, prices will go up? You think you can confirm that by experiment, that you can think that I'm pretty certain that's going to be true because I just understand how people work. If there's more money about, then people will have more money and they'll, so the extra flow of money, well, I understand prices, I understand how prices work, it's people bidding and getting what they can. And to take today's news, if there's tariffs, things are going to be, there's extra tariffs, well, there's going to be more trouble making international trades. And what do you expect? Of course, the stock market goes down because they understand that. So you can confirm it by experiment, but there's something you can, surely there's pure understanding that you can apply. And as I said, there's the formal sciences, like computer science, where you don't seem to need either understanding of other people or experiment, though you can have experiment. You just need to read the code or whatever and see how it works, or prove mathematics. Yeah.
It seems like Popper probably wouldn't want to apply falsificationism to formal sciences. So
Yeah, that's right.
So how would you protect against people with an unfalsifiable theory just saying, actually, this is in the domain of formal science?
That's right. So mathematics was always a bit of a problem for the Vienna Circle and Popper himself. So what they did is they had a philosophy of mathematics that excused them, and they thought they pretty much adopted the philosophy of mathematics of logicism invented by Frege and Russell about 1900, which said that mathematics is not about anything, but it's just logic, and it's how to infer one thing from another. So in that case, it hasn't got a content, so you don't have to, it doesn't have to be falsifiable. Really, it's just a lot of tautologies. So that excuses you from having to worry about whether it's falsifiable or verifiable or anything.
Couldn't you take like psychoanalysis or astrology and say they're just rules for telling a certain story about a situation?
Yeah, if you could take those views, and in that case they're not sciences, they're pseudosciences.
It seems like you could claim that they're formal sciences.
Oh, claim they're formal. Well, but they seem to be deductions from theses that are themselves pseudosciences. So formal sciences say you prove correctness of a piece of code. There isn't anything you infer that from. It's just all there before you, and it's all self-contained. But astrology, you've got to start believing that there's causal influences from the planets. And once you do that, you can infer things like a formal science and have a deductive structure. But at the bottom of it is something that's not anything. It's just made up. And that's what would make it a pseudoscience. Because there's axioms that are just plucked out of thin air with no verification, no falsification, no nothing.
But then, like, what's the status of axioms in mathematics as compared to psychoanalysis, for instance?
Well, you could, some people did have an if-then-as view of mathematics that said that it is all about how to infer things from arbitrary axioms. But normally you think about that the axioms of number theory, say, are actually true about numbers, and you can check it that every number has one after it, and so on, and that 0 is the first number, and that you can understand that they're true numbers, whereas you can't go to astrology and say, I understand why Jupiter in the 7th house when I was born must mean that I'm a genius or whatever. There's just nothing there to see. But the mathematicians can invite you to go and see that the axioms of numbers are true. Bit tricky about geometry, but let's not go there.
Is there a formal definition for a falsifiable statement? As in, are there, I guess, a set of rules that might distinguish a falsifiable statement from an unfalsifiable one?
Set of rules. I don't quite follow what you mean. I mean, to say that all swans are white is falsifiable meant that there was some possible observation that would mean that it was falsifiable. Now, it's hard to say if it's more complicated. How, if you get further away from observation than that. So, are the truths of number theory falsifiable or not? This is not quite hard to say. I mean, there isn't any possible state of affairs or any possible observation that would falsify 7 plus 5 equals 12. But that's just because mathematics, that statement is necessarily true. So what if you counted 7 and 5 stones and got 13? What do you do then? Is that a falsification? Well, normally you say, I'm totally convinced of the necessity of 7 plus 5 is 12, but I'm not quite so convinced of my counting. Maybe I dropped one, or maybe I'm getting dementia or something. So yeah, that's what I say. It's very, very difficult to make what Popper is saying gel with mathematics. Yeah.
I'm interested in that, because even there it seems that the reason you believe, for example, that 2 plus 2 equals 4 is based on inference that people using the word to in a sentence with 2 plus 2 equals 4 leads to a 4 as a consequence. But it doesn't seem like the relationship between the numbers in some way different from the language use is itself susceptible to new observations changing whether or not it's true.
Yeah, but it doesn't seem to be true by language. I mean, 4 probably means the number after 3, so maybe it means 3 plus 1. If it means 3 plus 1, it can't mean 2 plus 2 as well. The fact that 2 plus 2 equals 3 plus 1 is not a linguistic fact. It's
like an abstract concept.
well, yeah, but it's not a conceptual fact either. I mean, it's how things must be. We don't seem to have got it out of our mind. No, it's how stones must be. Yeah, you first.
So there was a discussion about this, about again, there was the two ones, like the maths type sciences and the other sciences and so on. And you said that you require that there be axioms that are sensible, right, such that you can infer from those axioms some truth or whatever. How do you square that with what was said by Descartes? So the idea, right, is that you can't really have any axioms aside from that you exist.
Descartes said after you've got to, you exist, you could get onto the mathematics.
You need to believe in God for that. Right?
Yes, maybe he did say that, but I think most of us don't feel you need that detour, and that for formal sciences, for mathematics, at least for the simple things, you can know just because your intuition is really perfect to know that 2 plus 2 equals 3 plus 1. You can kind of imagine it or put it before you, and so you put 4 things down. It's 3 plus 1, and it's 2 plus 2. There isn't a possible way around that.
The outcome of mathematics isn't really in the science in the same way other science is science.
That's right. It's
So the
not
outcome
that.
is
You don't
only
need
things like
data.
mathematics. The outcome is only things like mathematics.
Yeah, that one.
Under Popper's formalism, taking into account what Descartes said, only things like mathematics are verifiable and everything, or falsifiable, and everything else is like a long stream of things that go back to something at the very bottom which is unfalsifiable, such as like my experimental apparatus isn't being
That's right.
messed about with by some secret.
That's right. So probably we get back to big skeptical problems about how do you know there's an external world out there. Well, yeah, that is a good question. But of course, we can't do science without, although we could do mathematics without believing there's an external world. We might get the grants for our genius, but it's true. That's a separate question. Probably we can't do it here, but one suggestion is that it's inference to the best explanation, and that's a non-deductive method of Bayesian philosophy of science that works. That's a different, but it works. So the idea is that in the simplest case, it's just like the explanation of the fact that all the observed ravens are black is that all ravens are black. So it's a simple explanation, and it's confirmed by the data. So it's being simple and explanatory is part of what gives it a good, makes it better. It makes it better than theory, for example, that all ravens up to the year 2026 are black, which is equally confirmed by the data, but it's kind of a klutzy theory inherently. So yeah, we should think along those lines. Yeah.
There's a situation in which 2 plus 2 is 5, for example. If you have a square comprised of 2 unit squares on either side, so it's a 2 by 2 square, and you're asking how many squares are formed by this diagram. Well, you have each of the individual squares, and you have the entire square itself. So it seems as if you're asserting that 2 plus 2 is 4, absolutely, you're making an assumption that you're talking about stones, for example, that aren't arranged in any particular order. Whereas, I guess in the real world, the whole can often be more than just the sum of its parts.
I think that's changing the question, changing the definitions of plus. I mean, that's true. So you have 2 by 2. If you have those puzzles where you have full 4 squares, 2 by 2, and how many squares are there altogether? 1, 2, 3, 4, and there's the big one. But that's not, the big one is not one of the squares added in 2 plus 2. The 2 plus 2 add up to 4 squares, but then there's another big square, and I think it's changing the definition of addition to do that. And I remember having a debate about this many years ago by some philosopher of science at UNSW, David Miller, in Unichem of all places at that time, which was the campus newspaper that allowed at the time was not just administration news sheet, but had letters to the editor, and he said, look, sometimes what if you put 2 rabbits and 2 rabbits in a box, it can perfectly happen that after a while there's 5 rabbits in there. So in rabbit arithmetic, 2 plus 2 can equal 5. And I said, look, that's not what addition is like. It's the fact that 2 plus 2 is 4 that tells you that in that situation they've bred in there, that an extra one has been created. And I think in all cases where you do that kind of thing, you will have changed the definition of the things, or addition. You kind of expanded the meaning of addition beyond what it really is.
I think we'll take one question from Jack, and then we'll keep going.
Yes, all right.
My question tied into the conversation here, and it was about whether or not you think the idea of falsification, if predicated on like the correspondence theory of truth, is contingent upon the verification of our senses accurately corresponding to an external reality. So why trust that our observation of black swans corresponds to black swans, or real black swans, on the basis of falsification? And the idea that our observations always correspond to something seems like correspond to something accurately seems only tenable under like some kind of subjective idealist theory of truth or something, like metaphysics.
Yeah. Okay. Well, science normally starts from the assumption that basic sense observation is veridical normally, and however, what about infants? They don't perhaps know that. And there's a great book called The Scientist in the Crib by Alison Gopnik, a psychologist in California, and some other people, psychologists there, and the US they've got different titles in the US and the UK, and one of them is The Scientist in the Crib, and the other is How Babies Think, and it's based on observations of newborn babies, and the idea is that they're like scientists. They've got to work out stuff, and amazingly, they're born knowing quite a lot. It's hard to quite work out what it was. And one of these researchers was very dedicated, and he'd be called from departmental meetings into the labour ward to film the babies. So they film the babies trying to work out what they know when they're born. And even there's a whole field of prenatal cognition, for some time before born, they know a lot, and it's of course methodologically quite difficult to work out how to work out what they know, but there are some methods. But the part of the point of the book was that babies from about the age of 1, they've got to solve all philosophical problems simultaneously. So they've got to work out that there's an external world out there that they can act on, and they've got to work out the problem of induction so that they can infer from the past to the future. Pretty soon they've got to work on the problem of other minds to work out there's other minds out there. And they somehow managed to do this almost always perfectly, and in an amazingly short amount of time. It seems, logically impossible, but there they are. But you can think of, it's all right, I think, to think of the problem of skepticism about the external world as a kind of proto-scientific problem that's solved logically by the same kind of methods, which is something like making predictions and checking them, and taking a realist attitude to your explanations, inference to the best explanation. Those methods. Once you're the baby that's got the hang of them, becoming a famous scientist should be easy.
Okay. On to the next question now. So you mentioned David Stove in your talk. Just to have a look at what kind of implications there are for this kind of philosophy of science. David Stove wrote a book called Darwinian Fairy Tales, where he criticized, I think, Dawkins' book, The Selfish Gene, and he basically says that evolution can't account for, it's not a very good explanation for sociobiological phenomena such as altruism, sharing and stuff, and it's more about, animals should be selfish. So what are your thoughts on David Stove's arguments?
So David Stove's last book was called Darwinian Fairy Tales, and it's anti-Darwinian, but it's a little hard to grasp what exactly he's against and what he's okay with. He says he's perfectly okay with the theory of evolution as applied to pines and cod, but the way people like Dawkins and talk about humans is just completely out of contact with reality. And rather, perhaps ironically, his complaint about sociobiological explanations, such as the explanation of altruism in terms of, let me go back a step. So a problem for Darwin's theory, agreed by in Darwin's time, was that it was based on competition between entities. So the driver of evolution was supposed to be competition between the fitter and the less fit, so that the less fit died out, and the more fit were left to breed. So you've got more fit things changing as you went along. Now, a problem with that was, how are you going to get cooperative or altruistic behaviour in populations explained when they're supposed to be competing with each other? And they came up with the theory that that competition was not so much between individuals but between genes, so that you could increase the proportion of your genes in future populations if you didn't survive, but you sacrificed your life for 2 siblings or 4 cousins or 8 great cousins or whatever, because then your genes would continue even though you didn't. So there was a kind of talk about group selection, and they also had a theory that it sort of groups that were altruistic, the whole group could survive better because they'd be helping each other in a sort of you scratch my back and I'll scratch yours way. So, but the trouble with this is that it got like the explanations, it could explain everything, or explain everything in a bit the same sense as Popper was complaining about with Freud and Darwinism. So this is, for example, and that's why the title of the book is Darwinian Fairy Tales. That whatever happens, the sociobiologist can think up something. So if they're saying that they say that humans or any species should have, people are trying to have as many descendants as possible. But plainly this is completely untrue of humans. And there's people are deciding to go into monasteries, and there's homosexuals and everything. They're not having as many descendants as they could. I think the only person I've heard of that seemed to be really trying to have as many descendants as he could was Jeffrey Epstein, who had a very weird theory that he was going to impregnate with his sperm thousands of women. Well, that didn't quite happen. Even Elon Musk is not really trying to have as many children as he can, though he's definitely out there more than most of us. But so this is a story that I remember David Armstrong, one of the top Sydney philosophers, telling me. He put this quite seriously. He said, "Look, we can evolution can explain why women live longer than men. It's because grandmothers are quite useful for looking after infants. They got all those skills, but really old men are pretty much useless. So therefore, evolution is selected for longer lives for women." Well, I mean, this is making it up as you go along. It's very there's no good reason for this to think that that's true, and you could have evidence for it, but it's very hard to find actual evidence for these kind of things, because a lot of this stuff is supposed, like the evolution of ultra, is supposed to happen in the cavemen phase, and all we know about cavemen is, I mean, their skeletons are in caves. You don't know anything about their social behaviour or anything like that. So I think there was certainly something in what Stowe said, that the sociobiologists are getting away with fairy tales that they're not giving evidence for. Part of the problem is they're not giving theories that take risks and that something's counting against.
It's about like altruism in regards to like your children instead of the society. Like if the evolution is drawing you just have as many kids as you want, then you probably would just have the kid and then run off to someone else, have another kid and run off, right?
Yeah, that's right. So, but
most
whatever.
parents look after their kids.
That's right. So whatever happens, the sociobiologists have got an explanation. So it's people like screwing around and having as many kids as there are. Well, yeah, it's spreading their genes. But if somebody is is keeping to their family, well, yeah, they can explain that living in a family is great for survival of the children. So whatever, yeah. And I mean, part of the reason why philosophy people like the theory of evolution so much in among scientific theories is that they love have these causal stories that they can exercise their ingenuity and thinking up. And if you can't think up a good evolutionary explanation of anything whatsoever that is observed among humans or animals, then you're really not trying.
Okay, that's another question. Are there any methodological differences between social sciences such as economics or psychology and the harder sciences such as physics or chemistry? And if there are, how does philosophy of science distinguish the hardness of the science? Appropriate methodology for assessing claims in more or less hard
So I said something about this earlier, but not completely answer all those questions. So we kind of understand, I think the difference, what makes something a natural science versus what makes it a social science. That the social sciences are about humans as such, so not the biology of humans, but their behaviour. It's got certain what follows from them having minds, often in the mass. So economics is about, and sociology about humans in the mass, but psychology is often about the individuals. I suppose there's such a thing as rat psychology, and actually psychology students complain that there's far too much rat psychology. So there is such a thing as rat perception, of course, that you can study. You wouldn't really call rat perception a social science because it means human behaviour. So human behaviour kind of consciously human and intentional behaviour, and what follows from that, whether individually or in the mass. But okay, but natural scientist is anything else about physical reality, including biology, including medicine or something. So human medicine is about how our bodies work, and I just had a scan of an inside part here today, and which I'm glad to say has come out all okay. And you look at the scan there, and there's wobbling about, and you think, well, I know it's in me, but it's not. It's sort of not me. It's a far part of me, and maybe I could exist as a Cartesian ego without being bothered being connected by that stuff. But economics, it follows from, even though you observe prices and so on, those things couldn't happen without people making conscious decisions about buying and not buying. And then, as I say, there's formal sciences as well. You have to explain the difference between those. And some people had some good points about the differences in methodology. Was there any more in that question that we haven't said something about it, had some parts to it?
About like the methodology within each science.
Oh yeah, the methodology. So with natural science, you're pretty much stuck with thinking up a theory of normally a causal theory, and checking it against observations. And you do in social sciences you do that, but you have in addition kind of understanding how humans work and sort of inference. So of course it's true that something like theoretical physics is highly mathematical, but it's still not like a formal science, because you have to have some apparent contingent axioms to start with that have to be checked by observation. So Newton's law of gravity, it would be surprising if it wasn't inversely proportional to the square of the distance, but still you can't prove that. So it seems, and also there seems no way of proving what the constant of gravitation is. As far as we know, that's just a brute fact. And as people have pointed out, it's just as well that the constant of gravitation is exactly what it is to at least about 40 significant figures. Otherwise, we wouldn't be here. People are still worrying about what about that.
Go to the last question.
So we have the last question. I made it today, so we don't have it on the sheet, but I was wondering what you think your kind of philosophy of science has, to what extent it...
Do you want to hear?
Okay, sure. Yeah, to what extent does it affect religious beliefs? Because there does seem to be like this kind of argument where, religious beliefs tend to be unfalsifiable. And if they're unfalsifiable, they seem to be, things that shouldn't be believed. So I was thinking, to what extent does your philosophy of science have bearing?
Well, religious beliefs shouldn't be let off easily necessarily. They make some claims, and you should ask what the sort of evidence is for them. And especially because there are, as everybody is aware, there are quite a lot of different religious theories, but there are there's only one theory of quantum mechanics, although different interpretations of it. Well, yeah. So what? How should you think? If you think, well, look, I'm going to think about religion. I haven't thought about it at all before. It hasn't crossed my mind. What should I expect from it, and what evidence should I ask for? Well, it's not quite like a scientific theory, because it's telling you about everything. Is it falsifiable or not? It should be what it purports. Let's say an individual religion, what it purports to be is an inference to the best explanation. So the things that it's explained, so it's a bit like the existence of the external world or something. And as such, well, it could be all right or it could be not all right. So explain what? What's it supposed to explain that science hasn't explained? Now, there seem to be some things, at least in science, that science doesn't get to. Why is there something rather than nothing, for example? If you think that's a fair question at all, well, it isn't one that science is addressing. And religious people might say, well, there's a creator. So if science is going to tell you there was a Big Bang, and beyond that we don't know anything, it's just not going to address that question. So this is a little story from Richard Taylor's little book Metaphysics from the 1960s, which I think is still the best introduction to philosophy at all, ever. So he says, suppose that you are walking through a forest. You come into a clearing and you see in the middle of a clearing a perfectly spherical steel ball 1 metre in diameter. And you think, well, that's kind of surprising. I haven't seen that kind of thing before. You ask, why? How come there is that? And there are some right answers to it. It could be that it's laid by a giant steel chicken. Well, that could be quite reasonable. But what's not a sufficient answer is that there was a steel sphere there yesterday and the day before that. Well, there was, but that's not getting you anywhere with explaining how come there is one. And so now he says, well, there's an asymmetry between existing and non-existing. For something like steel balls, exactly. If there's no steel ball, well, what do you expect? There's nothing to explain. If there is one, there's got to be something explaining it. And he says, well, look, there's a number of issues, there's a number of aspects of this story that are just decoration that we can remove. Well, the forest is not doing anything, we'll just remove that. And the size of the thing is, the 1 metre is not relevant either. Let's make it a lot bigger. Let's make it like the whole physical universe. So why is there a whole physical universe? Well, it's made by a creator who's a necessary being or something of a different nature. That's a possible answer. But the fact that it was always there is not an explanation. So this is a dramatisation of what they call the argument, cosmological argument, that there's ought to be some kind of explanation in terms of a creator for the contingent beings like us and the whole universe, whole physical universe. Well, that's a kind of reason. And then probably, say, Christian or Muslim people are going to say there's some historical evidence. You can evaluate that the same as you do any other historical story. Is it a good story that Jesus existed 2,000 years ago and did the things claimed in the Bible? Well, if you don't think that, well, why do you think that the stories of Julius Caesar are more or less adequate? And as a matter of fact, Sydney is the centre of Jesus' non-existent studies. It is possible to maintain that there's no reason at all to think that Jesus existed as a historical person, but it's a bit of an uphill job. There doesn't seem anything wrong with it. It's historical evidence, even if you don't believe in the miraculous things or something like that. So it's very hard to know where to draw the line between the things you believe and the things you don't believe in the historical record. It's suggested also that there's, if you look at science and say, well, look, I think science, the scientific picture of the world is all there is. I don't need to believe anything else. There are a couple of suggested things that it's not doing a good job of explaining. There are two of those, ethics and consciousness. So David Hume said there's But ought is very different to is, and you can't deduce an ought from an is. That no matter what factual things you lay down, you can't conclude any ought statement from. There's just no way of deducing ought statements from is statements. And if you could conclude that there are no oughts, and you can do anything you feel like. Of course, there are some people that are fairly keen to make that conclusion so that they can do whatever they like. I wouldn't get together with them too closely. I hope you don't get married to one of those. If you think there is ethics objectively in some sense, then it's very hard to fit into the scientific world picture. The other thing, how they're doing with consciousness, David Chalmers, probably the most famous Australian philosopher at the moment, or perhaps not, perhaps Peter Singer is, talks about the hard problem of consciousness. All the neuroscience that you do seems to somehow not be bearing on consciousness in the sense of what it's like to be me, the internal world. We can have as many correlations as we like between our thinking and our experience, our perceptual, our inner experience, and our brain activity, but it's not the same as identifying it with the brain activity. There seems to be some gap. And science's effort to really get to the point of consciousness seems to be not happening. And I think we understand this a lot better now that we've got AI, because we understand AI does stuff that it produces text that's pretty much perfectly identical to what people do when they understand something and produce text, but we know there's nothing in there. When it does make a mistake in translation, it does something completely haywire. I was behaving as if I'm talking to a person, but I remember I'm not. So what is the difference between an AI that's a sort of zombie and us that's got genuine inner experience? It seems to escape science. And that's not to say that religion has got a particularly good story. Well, it's got to give a story about those. It's not, but still, if you start thinking that science has got limits along those lines, you might be a bit uncomfortable about saying that science is all there is. So yeah, religion's can't be let off, and you can't just say, yeah, let's have faith. That's going to give you trouble. But if you allow it to tell a story of inference to the best explanation, well, it's in the ballpark anyway, and you probably should listen to it.
So it seems like in practice a big part of science is choosing which questions to answer. Like if you have particle accelerators and so many experiments you can run through, you need some order to do them in. So it seems like none of the theories that we've discussed here tell you which questions are like more important.
That's right. That's a very good point. So deciding, part of being a good scientist is deciding what's an interesting question and how you should go about addressing it. And you're absolutely right that there doesn't seem to be much in the way of good theory about that. And people have looked at, asked scientists how they do it, but they haven't got much coherent about it. There's a famous story from the 19th century about Kekulé, who was a chemist working on benzene and trying to work out its molecular structure. When he was getting off the bus, he suddenly had the bright idea that it's not a molecule, not like the ones pictured on this lady's front that is sort of branched, but it's got a hexagon, a structure in the middle, and that it's very symmetrical around that. Everything else pokes out from that. That turned out to be right, but he couldn't say, well, how I got this fantastic idea. He's just getting off the bus, and it came into his mind. So yeah, that's right. And in mathematics too, it's besides people who are good at proving, there's people that have great intuition about what's an interesting question. And it's very hard for mathematicians to say, although there's a lot of intuitive agreement about what's an interesting question. So you'd really like to know that, but they don't. Yeah, good question.
Is that even part of philosophy of science then, or is that like aesthetics or ethics or something?
People have asked. There is a field that asks about the relevance of aesthetic considerations in science. So fundamental physicists especially say they're often guided by aesthetic considerations, which they often mean symmetry. So they say a symmetrical structure or symmetrical theory really excites us, and we work hard to use that to design experiments that will confirm it, and often that's worked out. So there doesn't seem to be much explanation of why that should be, because maybe God designed the universe to be symmetrical, but maybe it's the divine aesthetic. But then again, people don't seem to have a good grasp of what is this. Explain to me why symmetry is more aesthetic than a mess. Well, there doesn't seem to be an answer to that either, so that's a problem. But there should be a lot more study of that, because people kind of recognise that it is important, but they haven't managed to grasp how to talk about it.
How would you divide a scientific from a non-scientific claim? How would you do that?
So I'm not sure I would be able to do it. It's so I wouldn't say that, say, a Freudian claim, let's say, or an astrological claim for that matter, is sort of inherently unscientific. Those things could be scientifically true. It's just that the evidence is against them. So I think the idea of finding an internal criterion to demarcate science from anything else was not really a good idea. So, there are such things as science of consciousness, okay, but the subject matter should be, what should the subject matter be? It should be about the kind of natural behaviour of things in some sense, but quite what that sense is, I'm not sure. But after that, any theory of what it is all right. It's not, so to speak, it's not that there couldn't be a science of consciousness, it's just that we're not getting far. Of course, there is a science of consciousness in a sense, though. Early experimental psychology was about, going back to the 1890s or so, they asked about things about the least perceptible change. So perceptible means subconsciously perceptible. So you learn something about consciousness. There's something like Wundt's law that is found across a lot of different perceptions. Something like the energy or perceptual input needed to make a least perceptible change in, say, colour or sound or something is logarithmic in the actual what comes in. So that if you've got very faint light, you can see a very small. You can see something caused by a very small change in ambient light, whereas if you're in bright light, you need a much bigger change in the input to see that in a sort of logarithmic scale. So it was looking at the connection between exterior input and reported conscious change as well, right? That's a kind of science of consciousness. So you can have science like that, but whether there's such a thing, there's not really a science of ethics, because it's not the right kind of thing. There probably isn't a science of God, because it's not the right kind of thing, even if there is a God. It's not. We have some kind of intuitive sense of what's natural.
Do you also, sorry,
I had a follow-up about my previous question. I wanted to connect it to something you started saying at the start, which was that like some people make a distinction between the observation of, or like all the observed swans and all of the swans in reality. And connecting into my previous question, I was wondering if, like you said, you said, I think that scientists would generally take it as like axiomatic that their senses will correspond to reality accurately. But if they don't rely on the verification of their senses corresponding to reality somehow, it seems like an arbitrary axiom that you could swap out with basically anything else. So maybe you could swap it out with psychoanalysis or something like that. But maybe I think there's like a subconscious reliance on verificationism when it comes to putting falsification.
Yeah, that's probably right. So you feel that your perceptions are sort of continuously verified.
Yeah.
And so you predict that you're going to walk down the steps and you see them, and sure enough, you walk down the steps and it's quite right. And every now and again, something doesn't go right, and you pulled up and you have to kind of see what the mismatch is like. And there are definitely well-known perceptual illusions, which you kind of explain.
So maybe the observed black swan is just an observed black swan, and it's not actually a black swan unless you rely on your senses.
That's right. So what is the alternative? Well, you can start believing you live in the Matrix or something, in which case everything looks as if you're in the external world, but you're not. So your evidence that you live in the external world is quite good, but you don't. Well, I think you just probably when you or when you were a baby, perhaps you entertained that situation, and actually some people, especially those who become philosophers, do entertain that situation. And a few philosophers, as you probably know, actually agreed with it. So Bishop Berkeley in the 18th century, he said, look, that's exactly how it is. There's only experience, and there isn't any real things out there. It's just God acting directly on our consciousness. And actually, he argued that there couldn't be any real things out there causing it. Pretty bizarre. Well, those things are logically possible, but they're not probably that good as inference to the best explanation, because they're kind of contorted. But strictly deductively, they could be true.
Do you think people who hold to falsification but reject verification are doing so inconsistently because they rely on their observations?
Yeah, that's right. So anything that's any skeptical thesis, whether about science or about the external world or whatever, faces the problem. Aren't you being hypocritical when you walk about the world? And you act as if you believe that you work in the physical world and that all swans and that all ravens are black or whatever. Why not stop being hypocritical and agree with that? Well, I think that is fair. Yeah, that's fair.
So the other question I had was in relation to the scientific claims. Would you say you agree with Popper that a scientific claim has to be in some way falsifiable? That's a necessary condition of a scientific claim.
Falsified. Well, not in his sense. No, I mean, it could be in the sense that I probably would say that mathematical proofs, mathematical claims are scientific and not falsifiable. But there's got to be some way of getting at them. That the falsifiable criterion is too simple. Falsifiability criterion says there's got to be an individual observation that would make it definitely false. But the things are so complicated that there's got to be evidence that's got to bear on it somehow, but it could be a lot more complicated than that. And as people were saying before, you've got to you've got to assume that your apparatus is quite good, and sometimes you conclude that it isn't. So you get an anomalous result that appears to falsify your theory. Well, there's different things you can conclude could have gone wrong.
The other question I had was, is the structure of mathematics and reasoning something like necessary conditions of possible experience, so the Kantian thesis? To what extent do you agree or disagree with that?
Well, yeah, I'd say mathematical truths are true in our world and all possible worlds. So any experience must be structured mathematically, and any non-experience as well. Mathematics is just how things must be.
So would you take then mathematical reasoning as the most certain reasoning, and that's the foundation for your Bayesian inferences about that which is the most probable theory of the way things are in the world?
Well, yeah. So the theory of Bayesian theory says that the relation of evidence to theory is itself necessary. That it's how it is in every possible world. So that in every possible world, the verification of a consequence renders a theory more probable. You can't start anything without that, and that is bedrock. Actually, maybe there's something I did forget to say at the beginning that to clarify a bit about the Bayesian reasoning. I was going to give another example of it that is very widely applicable, but people don't talk about very much. It's called the proportional syllogism, or argument from frequencies. So you remember we said that the basic example of deductive logic was all men are mortal, Socrates is a man, therefore Socrates is mortal. All right, well, what about if 99% of men are mortal, Socrates is a man? What does that tell you about the conclusion Socrates is mortal? Well, you should conclude that it makes it quite likely, given no other evidence at all. Just the frequencies tell you what's probable. So you get on a plane and you're taking off. You can be relaxed on takeoff because nearly all flights land safely. Although, now and again one doesn't. So that's certainly how you think. Your probability is aligned with the frequencies you know, and that is a rational way of proceeding.
Well, it seems to me that natural scientists, because they're not really thinking that hard about the philosophy of science, they've sort of just tended towards a more intuitive sense of what is right and what is wrong, and sort of having falsifiability kind of as a technical thing that they probably believe, but not the core approach that they take. Do you see any changes in the future that scientists might tend towards even taking their intuition more into account in their philosophy of science, as a sort of collective intuition changing the de facto?
What is it? Yeah, well, of course they do rely on intuition to make conclusions, but they're not, generally speaking, very keen to say what it is. And actually they're kind of proud of the fact that they don't follow a method. But in fact they do follow a method. It's just you've got to lean on them to admit that, because of course they have a methodology, especially when it comes to statistical testing. There's laid down methodologies that to get your thing published, you've got to conduct statistical tests, supposed to be double blind, and they're supposed to pass at some level of statistical significance and so on. So there's methodologies there that agree with people's intuition of what you've got to do to rule out the hypothesis of chance, as they say in statistical testing. So, but in cases, in fields where there isn't much in the way of statistical testing, like fundamental physics, they still kind of agree on the intuitions, but they do disagree as well. So there's often disagreement. You get you get a new field of science or a new problem where everybody's agreed on what the experimental facts are up to the present, but they disagree on the conclusions you should draw, and they try to have experiments that will decide which it is. So, for an example is maybe 50 years ago, there were a lot of different theories about the origin of the moon. So was it a satellite captured from somewhere else, or did it sort of form from the Earth? When the Earth formed, was it kind of part left over, or and they formed simultaneously, or what? And they kept arguing about it. But then quite suddenly, the evidence got to a stage where everybody's intuition agreed, and they decided that, they concluded that it was made out of the Earth and it being hit by something else 4 billion years ago. And it's made of the same stuff as the Earth, and the Pacific Ocean is where it came out. So up to that time, the intuitions were different, and it's kind of reasonably different because there just wasn't the evidence, but then the evidence came to a certain point to make everybody agree sufficient. And I think that's probably typical. Yeah.
Yeah, so like on the distinction between how we ought to investigate things pertaining to the social sciences versus the hard sciences, the hard sciences, I was really hoping to get your thoughts on this early 20th century economist called Ludwig von Mises, right? And essentially he thought that because it was basically impossible or completely impractical to try and control the variables, right, in, say, all social sciences, those being humans, he therefore concluded that the best alternative was, in fact, to derive a priori theories about human behavior based off supposedly metaphysical necessities about humans, right?
Yeah, well, there's something just starting like that. Yeah, David, I mean, there have been attempts to do economics, say macroeconomics, with completely ignoring the social science aspect. So what you do is get all the figures about unemployment and production in different sectors and everything, and put them into a purely statistical model and see how it goes. Well, it kind of goes not that bad, but typically you find it's a completely blind or black box model. It does all right for a while, but it's not surprising really that it should predict short distance, which is sort of like predicting the weather. So weather is very complex and you can't get everything right, but you can make a model that it predicts very well for a few hours, and after that it's not so good, and there's nothing much you can do about it in weather. But yeah, it's perfectly correct that in economics you should be able to do better by looking at how humans are. So you should be able to think that surely prices are created a sort of aggregate out of people making decisions to buy given the resources they have, and you should be able to draw some conclusions from that. And I think what is observed is that it does work up to a point, but again, the model you get is kind of hard to fit to the data, and maybe it's just because there's so much going on, but it's probably correct that you do understand economics better by having that kind of sort of a priori model from human nature. But then, if you're going to do that, maybe it would be better to go and have a look at human nature from a psychological point of view. So if you model humans as rational, completely rational choosers of behaviour, then you're probably wrong because people are irrational to some extent. And you should need to factor that into economics as well. So what about the economic explanation of bubbles, speculative bubbles? So the famous first example of this was the tulip mania in Amsterdam in about 1610. So all of a sudden there was a speculative mania in tulip bubbles, in tulip bulbs, And the bulbs themselves are not worth much, but people started speculating them, and there was an enormous price rise, and the different kind of bulbs people, and it was completely irrational. There was no point to this, but people were irrationally speculating on the bulbs, and of course after a while there was a collapse and people lost vast sums of money. And every so often these kind of things, there was a South Sea bubble in the 1720s, and of course people are gambling on things, and there's mining, you get bubbles in tech stocks and so on. Well, you can't deduce a priori really how irrational people are. You have to go and look at how prepared people are to invest in get-rich-quick schemes, Ponzi schemes and everything. But yeah, it's certainly feasible to do some scientific research that is not quite the same thing as just observing price changes and employment changes and money printing changes over time.
So thinking about Bayesian view of science, it seems like the obvious objection is where you get your priors from, but then it seems like you can also say where you get your likelihoods from. So like if you have a deterministic theory like Newton's theory of gravity or Newtonian mechanics, then it's not obvious that likelihoods even come into the picture. Like either something is consistent with the theory or it's not.
Yeah, that's right. Well, one way of putting Bayesian theory is to say that, well, Bayes' theorem suggests this, that you should start out with a prior belief and then apply this Bayes' theorem to update it in the light of new evidence. Well, that's all right, but then where do you get the prior belief, your prior probabilities from? And there are some answers to that. The proportional syllogism is one answer to that. You get it from frequencies, and that is a kind of symmetry argument that says that all the things are equal. And the symmetry arguments are quite good at getting priors to start with, though there are some problems when different symmetry arguments conflict. But anyway, that's probably just too bad. That's how the situation is. But whatever about that, none of that bears on the rationality of the verification of theories by their consequences, which certainly applies to gravitational theory or any fundamental physics like that at all.
I have any other question?
So, sorry. So having to ask a question. How do you square theories where they make some prediction and then, in some sense, I'm just talking about ad hoc theories, right? You make some prediction and then the prediction is incorrect or whatever, and then you need to update your theory based on the prediction. Like, in principle, the question sounds like the answer should be obvious, is that it's an ad hoc theory, but also in some sense, that's how science works, right? Is that you make a prediction, and if it's incorrect, you might want to update your theory, say, okay, well, I wasn't quite right about this, maybe it's slightly different. So it's something you might see in the hard sciences, quote unquote, right, with, say, things like string theory and standard model and so on. Like the standard model is most likely probably correct, but there are things that it predicts incorrectly, and they say, well, I need to update this theory such that I get this. But how do you say, well, this theory is sort of correct, they just needed to fix it in some way, and then say, compare that to like a theory by Chomsky or something where it's like, this guy is just going to change his theory every time he does an experiment kind of thing.
Yeah, that's right. Well, that's a dilemma that you can't probably answer in general. But yeah, so if you keep having to make fixes, sort of little fixes to the theory to cope with things going wrong, then after a while you have to think the weight of epicycles, as you call them, it has got too much, and you're just chasing your tail. You're just not being honest. But where that point comes is hard to say. So of course, lots of theories, and especially in theories of very complex systems, say in medicine, it's typical that there are, the predictions are not really terrific. Sometimes they get a fair bit right, but you probably know that you get a feeling that something's wrong that you haven't quite put your finger on. And I mean, that's how it's coming out with the stories of the biggest cosmological stories about astronomy. They're concluding, well, they're doing a great job. There's something not right in there, but we don't. And they're thinking, well, we don't know how to fix it. We'll just have to keep at it and draw the conclusions and compare them and hope that someone figures it out.
So what's the problem kind of is like there's this like theory of science or philosophy of science, but then when things sort of get hairy, it's like there's got to be some heuristic in there that you're saying, like a feeling, but it's like what is the heuristic? Like why is the feeling about the standard model or whatsoever different to some other theory?
Yeah, well, it's partly about how explanatory and simple it is, so that's good. But then if your theory is explanatory and simple and getting too much wrong, then that's not good. So there's some trade-off to make between how well it's predicting and how simple and explanatory it is. So you can get very locked into a theory that you think is explaining things very well, and of course, it's your pet theory, and you've got that. You keep getting grants for it, and your graduate students keep giving you the data that supports it, and maybe deleting the others because they've got to get employed in the next grant. I don't know. So, but somebody has got to stand back and say, is the weight of ad hoc fixings getting too much, or isn't it? But it's very hard to give any recipe for saying when that is.
So I wanted to narrow down the topic of idealism. So I earlier, let's look at Berkeley's claim and ask, what do we even mean to say something exists if we don't mean its existence in some sort of sensible quality? So then when you're assessing whether or not a claim, when scientific realism makes claims about things existing which are not sense qualities, how is it that you can have a scientific realist viewpoint which makes claims about things which are not sense qualities?
Well, any inference for the best explanation should be able to take a realist view of the thing out there, and it's got to be doing some work and explaining something, but it doesn't have to be producing something sensible exactly. So the typical case is the baby infers there's other minds. Well, other minds are not sensible, but they're sort of in other people's heads, and they're doing some work explaining why the hell they're behaving like that. But all there is to see is mother or child behaviour or so on. The other mind is an inferred entity that's nonsensible, but it seems perfectly reasonable, in fact necessary, that you do make those conclusions.
I think there would not be the kind of claim I would be talking about, because you could infer the existence of another mind, but you can still describe what mind is in terms of potential sense qualities. So is there things that in some way exist, but which are not potential sense qualities?
Well, the other mind is not potential sense qualities, it's thinking. It's thinking sort of like yourself. But, you could infer... Well, I mean, atoms are not producing sense qualities. They're inferred to explain the cause of things that are sense qualities, like the things you see in the cloud chamber. What you see in the cloud chamber is not atoms. It's sense qualities. And the atoms are things that can't be perceived. They're just too small.
So if there's everything, if we look at the universe and we imagine that it's a set of things which are observed or in some way sense, and then there's a set of things which aren't observed or aren't sensed, in what sense do the things which aren't observed or aren't sensed exist? Is it just as a mathematical structure?
No, they're supposed to be actual entities that cause the things that are observed.
And is their existence, for example, shape? And if it's shape, then how is the shape? How do we even know what we mean by shape, if not the shape of something demarcated from something else in qualities, which we only understand through our perceptions?
Well, take shape. I mean, we perceive shape, but then we understand that shape is out there, even if unperceived, that it's part of space, that it's, that, say, space can be filled up with cubes or something, but it can't be filled up with spheres of the same size. I mean, the fact that we perceive that it, so to speak, that shape is not just perceived. We perceive it as the kind of thing that does exist in itself in the parts of space and in external objects. We're not so sure about colours, but because we feel that colours are maybe just perceived, but there's something out there, we perhaps don't know what, in a physical and shaped reality that's causing them.
So you would agree with the inference of certain mathematical relations, like, I'm assuming shape, that's how I describe it as mathematical relations, existing regardless of sense of them?
Yes,
yeah.
That's right.
And that those exist without,
Yeah, so for example, one reason why we have a good feel for the reality of shape is that we get it from different we perceive it from different sensory modalities. So you can see shape and you can feel shape, and we don't have a tendency to think that felt shape and seen shape are sort of different things. We think there's a real shape out there, and it's perceived in those two different ways. And that's part of the reason why we give it, where we attribute it to that external and nonsense reality, whereas colour is not like that.
So when we're saying something like the cosmos is flat, or that seems like the best explanation for the observations is that the cosmos is flat, what we're saying is there are these entities which exist, which are only as mathematical relations, but we're not making a claim about there being any corresponding sense qualities to those things which has to exist.
That's right. And there could be things out there that, in fact there are at the non-atomic level, things that just can't be perceived for one reason or other. Our senses are not up to that. Perhaps in principle something else could perceive them, but we certainly can't.
And then would you count inferential reasoning as in the same status as these mathematical relations which exist regardless of sense qualities? So as in they don't need a corresponding sense quality to have meaning when you say that they exist?
Yeah, that's right. Well, they need, yeah, that's right. They need some causal powers of some kind, but they don't need anything perceptible. So magnetic fields, I mean, whether we perceive them or not, there's good reason to think they're out.
So you reject instrumentalism?
Yes.